Lesson 18, Precalculus, Chapter 3, Exponential and Logarithmic Functions. We're on Section 1. We're learning today a new function to add to our library of parent functions, and it's the exponential function. F of x equals a to the x for a greater than 0 and a not equal to 1. I wrote it down again for over here because it didn't print out very bright. And it's different from the functions we've studied because it's an exponent, and its distinguishing characteristic is the rapid increase that the graph makes. It just flies up. You've heard the word that it grows exponentially. Like down here, you can see a picture of the exponential growth. Here it's exponential decrease because it's raised to the negative x. But we're seeing right now COVID-19 and how it's just got exponential growth. Sometimes it decreases because we're all behaving, staying in, and trying to avoid it. And then when we go out, one person has it, they give it to two, and each of those two give it to two more who give it, and it just, wow, it just explodes. So that's got an exponential growth. So we got a couple graphs down here to look at the basic characteristics of an exponential function. A to the x. The domain for both of these, when it's a to the x or a to the negative x, the domain is infinite. It's going forever to the left and forever to the right. So the domain's infinite. The range, again, you start from how low it is to how high. It starts as low as 0. It's got a horizontal asymptote, which is the x-axis, or you could say y equal to 0. So it's starting for the range as low as 0, and then it's going up to infinity. So the range is 0 to infinity with a parenthesis on the 0. Both of these have a y-intercept of 0, 1. On the left one here, it's increasing. Remember, when it's increasing, you put your little car here, take it a drive from the left to the right, and it's going up the hill. So it's got a positive slope, so that means that it's increasing. And over here, when you put the car on there, it's going down the hill, and it's got a negative slope, so it's decreasing when it goes from the left to the right. So since it has a negative slope, decreasing from negative infinity to infinity. The graphs are both continuous because there's no gaps or holes in them. All right. So we're going to use our calculator a little bit here on the next page. It says to evaluate. Use the calculator to evaluate. Evaluate means find an answer. Find a number. The function at the indicated value of x, round your result to 3 decimal places. It said to round it. So we're going to round it. It says f of x equals 3.4 to the x, where x is 6.8. So 3.4 to the x means 3.4 to 6.8. Instead of x, we're going to put 6.8 in for x. So using your calculator, let's see here. 3.4 caret's above the division symbol, and then 6.8, enter. And to 3 decimal places, it's a 3. So 4,112.033. The next one says 1.2 to the x. So 1.2 to the x, and x here is 1/3. So 1.2 to the 1/3. And that gives you 1.063. I'm going to round that 2 up to 3 because the number after it is 5 or more. So 1.063, or 1 in 63 thousandths. Okay, the next one is the e. Now e is like pi. You can find what pi equals on the calculator. It's above the caret key. Second, let me turn it back on. Second pi. That's what the number pi is. Likewise, the number e is down here above the word natural log. So second natural log 1. So I'm put it to the first power just to find out what just one of them are. So 1e is 2.71828. So it's just a number. It's a number like pi that we use for a lot of things. You could Google it and watch a video about e and the where it came from and who developed it. Euler developed it. So you could watch a video on it if you want. All right, next one, e to the negative x. So that's e to the negative 3/4. So that makes e to the positive 3/4. So second function e to the 3 divided by 4. So that makes to the 3 places 2.117. If you have an old calculator, make sure that you're putting, when you put it up to it, that you put it inside parentheses. The newer calculator raises the whole thing up and you don't have to worry about it. But if you got an older one, be careful. Okay, on the next one, they would like us to describe the transformation that yields the graph of g. Then sketch the graphs of f and g by hand. All right, f of x is negative 2 to the x, and g of x is 5 minus negative 2 to the x. So just rewriting that a little bit. We have negative 2 to the x plus 5. So from the left to the right, what happened is they added 5 to the function, to where the x is at. So that meant since you added it and it's outside the x, that made it a vertical shift up 5. So that's what changed on it. And overachieving on this, they didn't ask us about it, but overachieving, over here they have a negative on in the front of it. Also, again, that's outside of where the x is at. X is up here, so it doesn't affect the x values, it affects the y values. So this meant this graph from the parent function had, let's see, it affects the y, the negative does, so it makes it a reflection across the x-axis. From the original parent function, which is kind of fun to note. So doing the graph on the left here first, I'm just going to do them both by hand. I'm going to put in, let's see, negative 1, 0, 1. That should be plenty here. So if I put a negative 1 in here, that'd be negative 2 to the negative 1. So this minus is not for that. The exponent is just for the 2, because that's what is immediately to the left of it. So that makes it negative 1 over 2 to the positive 1, or negative 1/2. So the next one is negative 2 to the 0. Again, the 0 is just for the 2. Remember, anything to the 0 is 1. So that becomes 1, but the negative's out front, so it's negative 1. On the next one, we have negative 2 to the first, so that's negative 2. So we have negative 1, negative 1/2, and then 0, negative 1, and 1, negative 2. And this has the original asymptote on it of y equals 0, the horizontal asymptote. That's what the parent function's asymptote is, y equals 0. And it didn't change, it didn't shift up or down at all from there, up or down, because they didn't add or subtract anything. But on this one, now going from that graph to this graph, again, they added 5, so everything shifted up 5. So even the horizontal asymptote goes up 5. So 1, 2, 3, 4, 5 would make y equals 5 for where it's going to be on the new function, g. And then move all the other 3 points up 5. And connect those together. And of course you could check this on your calculator. I don't know, I like graphing things by hand, and it said to graph it by hand a little bit. It did say that here. It said, yeah, it said do it by hand. So it didn't say put it in the calculator. So doing the next, so going over one of the ways I like to talk about how to transform graphs. I mean, I counted up 5. So what happened there? The transformation was a plus 5 on the whole thing, so all the y's had 5 added to it. Nothing happened to the x's from the left to the right, from the original f to the new g, but all the y's had 5 added to it. So all the x's stay the same, but then you add 5 to all the y's. So 5 plus negative 1/2 is 4.5, 5 and negative 1 is 4, and 5 plus negative 2 is 3. So negative 1 was 4.5, 0 was 4, and then 1 was 3. So that's another way you could think about it. The only thing that's kind of fun to do on it is the range. So for the red one, for the range, again, going from low to high, it goes from negative infinity up to 5, but it doesn't include 5, so it's a parenthesis. And then for the purple one, negative infinity up to 0, but it doesn't include 0. The domain for both of them are infinite. And for both of them, it's decreasing from negative infinity to infinity. It's going down from the left to the right. Okay, next one, same idea. What changes from the left to the right? And what changed here, it says negative x plus 4 if you can't read it. Note, they have the negative pulled outside of it, which is a nice idea. Because you're not supposed to have, when you talk about the stretching and the shifting, you're not supposed to have a coefficient on the x at all. The coefficient of x is supposed to be 1, which is, there's nothing there right now, so it's 1. So because of the negative being there outside of it, what changed from the left to the right? And it's up with the x, so it affects the x. So it's negative, so that it's a reflection across the y-axis. And then because of the plus 4, you got to do the opposite, so it shifts left 4. If you want to say it fancy, you could say horizontal shift left 4. All right, so I'm going to graph it again here by hand. So doing the original one here, I'm going to do negative 2, negative 1, 0, 1. So if you use negative 2, so 1/2 to the negative 2, you're allowed to, if you recall back from Algebra 2, just flip the whole fraction over to make it positive. So it's 2 over 1 to the positive 2, which makes 4. And so 1/2 to the negative 1, again, flip it over, so it'd be 2 over 1 to the positive 1, so that's 2. And then we got 1/2 to the 0, which is 1, and 1/2 to the first, which is 1/2. So the original function here is negative 2, positive 4, negative 1, 2, 0, 1, and then 1/2. And it's still got that, because it's pretty close to being, it's still got the horizontal asymptote of y equals 0, because it's still pretty much the parent function for this original f of x. And this one doesn't have any shifting up or down, so it's going to have that same asymptote. And on the next one here, again, doing that trick on it I like to do, and I'm going to go ahead and distribute the minus across, so it's negative x minus 4, so all the x's are negative, and then subtract 4, but the y's aren't changing, so the y's all stay the same, 4, 2, 1, 1/2. But all the x's I'm going to change to negative and then subtract 4, so I'd make positive 2 minus 4, negative 2, and then positive 1 minus 4, negative 3, and that would be negative 4, and that negative 5. So negative 2, positive 4, negative 3, positive 2, negative 4, positive 1, and then 1/2. So again, they both have the asymptote there of y equals 0, but the new one again reflected across the y-axis, and it went left 4. So I don't know, they both have a domain that's infinite. The range for both of them would be the same if you did the range. Again, going as low as you can, it would be almost 0, and then up to infinity. I guess it's kind of fun that the purple one here, the new one, is increasing from negative infinity to infinity. The red original f function is decreasing from negative infinity to infinity because it's going downhill left and right. So this one's going uphill, so positive or increasing. Kind of interesting. All right. Next up, we're going to do formulas for compound interest. So the formula for compound interest is the amount of money is equal to the principal times 1 plus the rate divided by n, the number of times it's compounded, raised to the nt. Again, T is time in years. T is time in years. A is the amount, like the amount that you borrowed for a car loan, or the amount you put in the bank that are an interest on. And then P is the principal. Oh, all right. P is the principal. That's the amount that you borrowed for, like, if you're borrowing a car, or the amount of money you invest. And A is how much money is actually in the account at the moment. A is, let's see, the balance A in the account. All right. The balance in the account. Sorry about that. But P is the original amount that either you invest in putting it in a stock market, or that you put in the bank to earn the interest on, or it's the amount of money you do for a loan. Another one here we're going to use is Guido's formula for continuous interest. A equals PER to the T. So it kind of spells the word PERT, which is a shampoo you can buy. Be careful on it. The R is the interest rate, and whenever you use the interest rate, you need to change them to a decimal. So if it says it's 2.5%, move it over 2 places to make it 0.025. On the next page, we're going to do a whole bunch of problems with it. So we need to find, we're going to invest $2,500, and we're going to have an interest rate on it of, down here, 6% for 10 years. What if we get it to compound once a year? So that when we're putting it in for 10 years, so every year at the end of the year, it's going to compound, and then we're going to earn interest on that interest, the new amount. So again, the formula is A equals P times 1 plus R divided by N to the NT. So when N is equal to 1, meaning it's compounded annually, once a year annually, the amount that we would have after 10 years, take the principal, $2,500, times 1 plus the rate, which was 6%, 0.06, compounded once, into the 1 times 10. Again, you're using N twice here. So then putting it in our calculator, we have got 2,500, parentheses, 1 plus 0.06 divided by 1. I know you don't have to write divided by 1, but it'll come in handy in a second. And then raised to the 1 times 10. And we get $4,477.12 rounded to the nearest penny. I don't think your bank will round it, but I'll round it. Next up, you got semi-annually. When it's 2, you're earning interest twice a year. So you'll earn interest on your interest, which will give you more money. So the amount would be 2,500 times 1 plus 0.06 divided by 2, the 2 times 10. All right, so now what you can do is hit second and then enter, and it pops your old equation up back by going second, enter, and then you can just go back and type over things. So I'm going to type over the 1 with 2's because I changed my n to 2. So that made 4515.27. And then they want us to do 4, which is quarterly. 4 times a year. 4 quarters and $1 is quarterly. So again, hit second, enter, and I'm going to change that to the 2 to a 4. And then you've got $4,535.05. Then you've got 12, n equals 12. When n equals 12, that means you're earning interest monthly. So we need to replace the 4 with a 12 now in that formula. So second, enter. And I'm going to change that 4 to a 12, so 1, and I'm going to hit second, insert, 2, oh, I think that's a Z or something, here we go, and then I'm going to hit 12 up there, enter, and I get $4,548.49. The next one on the table said 365, so that means you're earning interest daily. So we need to replace that N now with a 365. Almost probably easier just to retype it at this point to get all those numbers in. Okay, so $4,555.07. The last one on it on the table wanted to know about continuous. So if Guido's loaning your money, you got to use the continuous formula. So the amount of money equaled PERT. So the amount was that we invested here for the principal was $2,500 times e to the rate 0.06, and the time was 10. So 2,500 e 0.06 times 10. You get $4,555.30 when you round it, because the 9 becomes a 0 and rounds that 2 up. All right, see you for the next lesson.